Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, we will be quickly moving on to our topic of discussion. We have been discussing about the chapter machines. Today we will be discussing the second part of the chapter machines, that is pulley. We have already discussed about machines, their functions, and also discussed about lever. Okay, so today we will be discussing about pulley. So let us now consider what kind of pulley that we have to study. Okay, and what is actually pulley. Okay, so first of all, let us consider what is pulley. Okay, in the previous video we have said that we will be discussing about the examples of lever in our human body, but due to some problem we will not discussing those topics in today's class. We will be discussing pulley. I think we will be discussing this topic in the maybe in the next class. Okay, but definitely we will be discussing. Don't be tensed. Okay, we will be definitely discussing those topics. Okay, so with that let us start. So first of all, consider what is pulley. So have you seen in the rural areas that there are wells in the villages, isn't it? There are wells in the villages, and from those wells water has to be drawn out from the well using bucket, isn't it? So it is difficult to just pull up the bucket of water in the upward direction. Say if this is the well, okay, so this is the well. So if you want to pull up the bucket, if here is the bucket of water, and if you want to pull up the bucket like this, if the rope is like this, pulled up like this, okay, so you have to apply the force in this direction, upward direction, isn't it? Upward direction, okay. So it is difficult to apply this force in the upward direction, isn't it? Just imagine that you want to lift the bucket, you have to pull up the bucket like this, so you have to, it's quite inconvenient to apply the effort in the upward direction against the force of gravity, okay. It's quite difficult, isn't it? So there comes the usefulness of the pulley. So what does actually pulley does? Or first just let us consider what a pulley is. You can consider a pulley to be a circular disc, okay, a circular disc. So if I consider pulley, what are the points that I should be discussing? It's a circular disc. So first of all, it's a circular disc, okay, and it may be made out of wood or metal with grooved rim around it, So you must be wondering what this grooved rim is all about. Just consider the example of the wheel of your cycle. I think all of you have sometimes or the other used bicycle, and if you just think of the wheel of the bicycles, okay, you will just consider steel part, isn't it? Have you ever seen when the tire is being repaired, the tire is being opened, and the pulley, the steel part of the wheel can be seen easily. I think you have observed that there is in order to hold the tire in the tube, the rim of the wheel is somewhat grooved. That means if you just have the upper view, it will be something like this, okay, it will be grouped like this, isn't it? Like this. So it will be grouped like this. So there will be some hollow, just shallow part here, okay, so that actually the tire tube can fit here, isn't it? Okay, so that is a grooved rim. So pulley is basically a circular disc made up of wood or metal, okay, with grooved rim and with a rope or string wound around it, okay. So this is the basic definition of a pulley. So I think it is clear, okay. So it's a circular disc with a grooved rim, wooden or metal, and there is a string or rope wound around it, okay. So this is the pulley. Now and there is a frame to which this circular disc is attached with a axle, okay. So fifth I can write, there is a frame, okay, to which frame to which this disc is attached by an axle with the axle being tightly pivoted to the frame, okay, with the help of some nuts or say maybe nails, okay. So this is if you consider the structure of pulley, this is the main structure of pulley. If you want to see the actual figure of a pulley or actual structure of pulley, I think it will be better just if you search on your internet that the image of a pulley, you will be able to see the images. As I am not using a digital board, so I will be not drawing the diagram of the pulley, as because it's difficult to draw the three-dimensional figure, okay, and I am not very good at drawing, so please pardon me. Just log on to the internet and see the images of the pulley. I think the concept will be very much clear to all of you, okay. So actually what we have been doing, we have been just trying to just add up the structures which make up a pulley, okay. So there will be a frame, there will be string or rope which will be wounded on the groove rim, and the groove rim is present on the circular disc made up of wood or metal. So this is the basic structure of a pulley, okay, fine. Now consider now this pulley can be of two types, okay. This pulley can be of two types based on the fact that either this frame is attached to a rigid support or not. Based on that fact, pulley can be of two types, okay. So just now let us quickly move on to the types of pulley, okay. So what are the types of pulley? If I consider the types, okay, so what are the types of pulley? Okay, so what are the types of pulley? So consider the types. So depending on whether the frame is rigidly attached or not, pulleys are of two types. One is the single fixed pulley, and the other is the single movable pulley. Now if I consider a single fixed pulley, okay, if I consider single fixed pulley, what do you see? If you consider single fixed pulley, the frame is being rigidly attached to the support. So if I just draw the diagram, it will be somewhat like this. Okay, so first of all, just let us discuss the single fixed pulley. Consider its structure, single fixed pulley, okay. So I am just drawing a schematic structure so that it will help you to understand the concept in a better way. So just when you are seeing from the side, this is the circular disc or wooden disc, okay, and here is a rigid support, say ceiling of your roof, okay, and to this the pulley has been attached firmly, okay. So this has been attached firmly to the pulley, okay. So this is the structure, and the rope is actually passed over like this. The rope is actually passed over like this, okay. On one side of the rope, you apply the load is being hung, okay. So this is the load, and on the other side, the effort is being applied like this. So the effort is being applied like this, okay. So this is the structure of single fixed pulley, okay, isn't it? I think the schematic diagram is clear, okay. So if you consider this diagram, there is a single string or single rope that is being wound around the circular disc, isn't it? So that single string or single disc, remember one thing, I think you have all learnt about the tension force in class 9. There are various types of forces. Tension force is a contact force, and which always exists in the ropes or strings, okay. Whenever you consider a single rope, remember this thing, whenever you consider a single rope, single string, the tension throughout the string is same. Remember this thing, okay, fine. So if I consider as a single string, so I will be considering that the tension for the rope is being tension T, okay. So if I consider the tension T, and now tension always acts from the direction of the applied force. So here the load is actually acting in the downward direction. the load is being actually acting in the downward direction. So definitely the tension here will be acting in this upward direction, and since the effort is acting in the downward direction, also the tension here will be also T acting in the upward direction. So if I consider the mechanical advantage of such single fixed pulley, okay, mechanical advantage of such single fixed pulley, what will be the value of the mechanical advantage? So we know that mechanical advantage is equals to load by effort. Okay, so load is also equal to one tension T and effort is also equal to tension T, so both cancels out and the value of the mechanical advantage turns out to be 1. Okay, so the value of mechanical advantage turns out to be 1. Now, so have you remembered that when the value of the mechanical advantage is equal to 1, what will be the function of the machine? It will definitely not work as a force multiplier, it will definitely not work as a speed multiplier. Then why are we actually using a single fixed pulley? Oh, so okay, so just think of this fact. We will be coming to this point, not now, but what will be later. Okay, so just consider this fact: the mechanical advantage is equal to 1, and just if you can imagine, I have no 3D figure or motion figure to actually demonstrate the fact that when you just pull this effort point to through a certain distance, the load also moves through the same distance. Okay, so the if you consider that you are just moving this effort point in the downward direction, as much as you move down, the load point is actually moving up by that same distance. Okay, so if I consider the velocity ratio of a pulley, then velocity ratio, as you have remembered, is the distance moved by the effort by distance moved by the load. This is also both the distances moved in a certain time by the load and the effort are actually equal. So the value will be, the ratio will be also equal to 1. So velocity ratio is also equal to 1. Mechanical advantage is also equal to 1. So if I consider a single fixed pulley, both the values are 1. And in case of an ideal pulley, the efficiency is actually 100%. As you can easily see from the formula that you have learned. I think you have remembered the formula regarding this. Mechanical advantage is equal to efficiency into velocity ratio. So obviously for a single fixed pulley, in ideal case, the velocity ratio and mechanical advantage are both equal and the efficiency is equal to 100% or 1. Okay, so I think you have remembered these facts. Okay, so now coming to the point, why the single fixed pulley is then after all used, isn't it? The fact is that why the single fixed pulley is after all used, although it has a mechanical advantage 1. See, I have in the beginning I have told that if you consider drawing out water from the well, just think of the situation that you are drawing out water from the well using a bucket and you are not using any pulley arrangement. So think in which direction you have to apply the effort. You have to actually pull up the bucket of water. You have to apply the effort in the upward direction. And applying the effort in the upward direction is quite inconvenient. It's quite not very easy to apply. So we definitely do not enjoy applying the effort in the upward direction. So we actually use the pulleys so that it can actually change the direction. See, the direction of the effort has been changed from the upward direction to downward direction, isn't it? It has been just using this pulley, the direction has been just rotated in the downward direction. Okay, so this is the main function of pulley, that it it's a machine which is helping to apply the effort in a more convenient direction. So this is single fixed pulley. Okay, fine. Now just quickly moving on to the next topic, the single movable pulley. So I think these concepts are clear. If not, please pause the video, move back a little bit and again just go through it once. The concepts I think will be absolutely clear. So next that we will be discussing is single movable pulley. Just remove this fixed and write it as movable. So single movable pulley, okay? Single movable pulley, okay? Single movable pulley. So what is single movable pulley? In this case, the frame of axis, the frame of rotation, the frame is not actually fixed. It is actually free to move. Okay, so the diagram is something like this. Here is the frame. Okay, and the load is being attached to this point. Okay, load has been attached to this point. So this is the load acting in the downward direction in this way. Okay, and actually the string, one end of the string here is attached to the fixed support or the ceiling above. Okay, so it will be something like this. Okay, like this. Okay, So here actually we are applying the effort in this upward direction. Okay, like this. Okay, so here the tension T will be acting upward as it is because supporting the load, and also in this part here the tension T will be in the upward direction, and here the tension T will be supporting the load. So just think of the fact, think of the figure. I think that diagram is clear, that the two tension forces will be supporting the load. Okay, isn't it? As because the axis and the wheel is being just hanging on this rope on the both the sides will produce a tension that will be supporting this load. So in case of the single mover pulley, the axis of rotation, see the axis of rotation is not fixed. It has been free to move. One end of the string is fixed, and one end of the string we apply the effort, isn't it? So if I consider the value of the mechanical advantage, what will be the value of mechanical advantage? Load by effort. Load is equal to 2T, effort is equal to T. So it turns out to be 2, isn't it? Okay. So actually single movable pulley is acting as a force multiplier, but that is one disadvantage. Can you just think of the disadvantage? Just think of it, and we giving the answer a little bit later. So it's a force multiplier and having a value of mechanical advantage 2. And if I consider the velocity ratio, actually when you pull up the load, when the effort point moves up by load moves up by distance of x, the effort actually moves up by distance of 2x. Okay, so considering fact that the effort moves up by distance of 2x, when the load moves up by distance of x, the velocity ratio is also equal to 2. And in ideal case, we know that the from the formula ma equals to efficiency into velocity ratio, the velocity efficiency of a single movable pulley for ideal case is actually 1. Okay, so on 1 or 100%. Okay, fine. So this is single movable pulley. What is the disadvantage now? Disadvantage that again you have to apply the force in the upward direction. So again that disadvantage comes in front of us, that you have to apply the force in the upward direction. So will we not use a single movable pulley? Yes, definitely we will use, because it's a force multiplier. So how can we change the ratio? How can we change the situation? Just imagine if I just use another fixed pulley with this movable pulley, then I think the situation will be something different. Just here, if you consider another single fixed pulley being attached to the axis, okay, they attached to the ceiling, and now if I just move around the rope like this, if this rope is moved around like this, now see, now we will not have to apply the force at this point. Okay, we will be applying the effort rather in this downward direction, isn't it? And here tension T will act. Okay, so see that disadvantage of the single movable pulley has been removed using a single fixed pulley in coordination with it. Okay, so if I use a single fixed pulley in coordination with a single movable pulley, it is a very good device, and is because it has a mechanical advantage of 2. That means that we have to apply the half effort in order to lift some load of certain weight. Okay, so this is single movable pulley. Okay, fine. Now today we will be stopping our class here, as because time is not permitting us. In the next class we will be discussing some other kinds of pulley, combination of pulleys, and we will be seeing the mechanical advantage, velocity ratio, and discussing the remaining topics of this chapter. And in the next class we will be discussing about the numericals. Okay, in the numericals will be provided to you in the digital board class. Okay, so in the next class we will be completing this chapter by discussing the combination of pulleys and examples of lever from a human body. Okay, so till the next class, please do study well, and if you have any query, please mention in the comment section. We will be happy to solve your problems. Okay, so till then, in the next class, see you in the next class. Thank you. Goodbye.